stirrer as well. So I'm going to leave this kind of tray here, and the tray has the oxalate in and the solution of ferrous, ferric. Ferrous is iron 2, ferric is iron 3. So there's some solutions made up, and it informs you only need 8 ml of iron solution. But can I just ask you, I've kind of printed a script out yesterday that I could have altered before doing some mass photocopy. I don't want you to use potassium oxalate at 12 grams and 20 ml of water and 8 ml of iron 3 chloride. I'll write it on the board. I want you to use 6 grams of potassium oxalate, the same quantity of water, and the iron 3 chloride to use 4 ml. The reason that's the case is that the oxalate is ferociously expensive, and I don't want to obviously buy another £100 bottle in a week's time because we've used all the reagents up to date. So the oxalate is expensive. So instead of using 12 grams, I'll just write it up now. You need to think about potassium oxalate at 6 grams, water 20 ml, and the ferric solution, the iron 3, what's it say in the manual, 8 ml? Yeah, so 8 ml, so use 4 ml. So just tweak your volumes and weights that way. So, how do we do this? Well, this is a heating mantle. And today you need to get yourself a mantle. You need a clamp and stand. So mantles are kept in this drawer down here. So by the sink areas, they should clearly say on the drawers, stir hot plates. So get yourself a mantle. You need a stand, which at the moment are kept down the side islands of the bench. So get yourself a stand. And as well, you need a bottom clamp. So you've got bosses and a clamp. So get yourself a bottom clamp. And when you're using a hot plate, it's always better to put the hot plate as a weight of the equipment onto the base of the stand. Because if you knock anything over, it's a more substantial weight to tilt over at this point. Some students use things like that, so you can easily knock things over. You haven't got the weight of the hot plate holding this down. So make sure that the hot plate sits nicely onto the stand, and assemble yourself a bottom clamp together as likewise. So take the boss, thread it down, and then put the clamp on. And when you're fixing the clamp to the boss, make sure that the length of metal here sits on the ledge of that side of the boss. So again, there's an extra security in case that fulcrum, that kind of rivet moves, it doesn't just drop out like this. So if you were to assemble it that way, and this was wobbly, it could easily at the point drop out. So if you just moved it the other way around, even if you couldn't tighten that properly or it came loose, it's not going to drop. And I say that because every so often you see students with a glass that's flat, a glass glass that's smashed on the bench because they've not assembled this correctly. So you then need, as it says, a glassware vessel to stir with. So get yourself a flask, get yourself two from down here, a magnetic flea, and as well you might want a spatula. So it tells you to go and get about 6 grams of oxalate. So around the lab as well, we've got balances left around. So I'm just going to quickly go towards one balance area, which is over here. And you've got a selection of balances. You've got a 4 DP balance and a 2 DP 2 decimal place or 1 decimal place balance. So I'll put my flask on and I'll stir the apparatus. So what I say to some of my students as well is that a good chemist, and I'm not being a good chemist this morning because I've no lab coats on for a start, but I've got gloves on today, which is remarkable for me. But a good chemist always turns his apparatus to 0. He or she puts the flask on, and you'll have a lab book or today's pieces of paper, but you'll write down somewhere the weight of the apparatus just in case you forget it during the exercise. You forget a weight or something. So you could write down weight of apparatus 64.3 grams. You tare it, and you weigh, if you always can in chemistry, try and weigh into the apparatus you want to weigh. So today it's in organic, try and weigh into the apparatus. So it says 6 grams. So if I'm right-handed, I try and work close to the vessel that I'm using. Now you could take the glassware off and transfer to small distance so you don't spill anything. So we'll try doing that for a start. So we'll just put a scoop in and weigh it, which is 1.1 gram. But what's bad form is moving it over a large distance and spilling it all over the balance area. So you can either think that you've got the skills already in place and put the spatula with the material over the top of the flask and pour it in. Or if you're unsure of that, make sure that you have a small transfer distance and throw yourself what you believe to be 6 grams of oxalate. So that's 7.2 grams. So I need to go and fish out some of the sample, pop it back in there. That's 5.9 grams. So I'm happy with that. So if I had a result sheet on a lab book, I'd be writing 5.9 grams of oxalate moved in. Now it says 6 grams. You've got a bit more time. You can actually, spend a bit more time and care moving the sample into the flask. So you bring the oxalate back. Your spatula has got oxalate on, so that's probably best to go by your sink area. And we'll put some bowls out so it can go in there, some cleaning bowls so it can go in there. But what's good form for a chemist, knowing that you've just worked with a toxic substance, is to take some water and rinse the spatula with it before putting it in an appropriate glass bowl. Because of course you're making sure in the eye later on, as the dishwasher for the afternoon, it doesn't pick up a spatula full of oxalate. So just rinse that way. What that will do to the fish in the River Irwell is another matter, but never mind. Then what can you do? Clamp the flask into position like this. So when you're clamping glassware, just put it securely, tighten it like that. Don't squeeze it and tighten it too far, that you'll shatter the glass. So that's gently clamped, but it's in good position. Drop down, and then take a flea and put it in. One thing just to say to you at this point is that I say take the flea and put it in. I'm not really explaining as such what a hot plate stirrer is. So for our newer people today, if you have a hot plate stirrer, you hold it up, you'll see 2 buttons, a motor and a hot plate. If you switch it on at the mains, which is always helpful, so switch on at the mains, hot plate off, put the spinner on and spin it. It'll do a little whirly motion. It's obviously good to spin. Always check your hot plate before you start. Don't set anything up and then realise the hot plate's buggered and it needs replacing. You have to dismantle everything. That's spinning. I've done this before, but check it heats by just turning the heating element on. Don't be too stupid and leave your hand on it while you sizzle and singe your hand. But just make sure there's a touch of heat coming out first, so you know it's heating. So this is heating, that's fine. You have 2 dials. Most hot plate stirrers now in this lab are between 0 and 10 on both sides. So 0 and 10 for revs per minute. More 10 is a faster rate of spinning. 0 to 10 on the heating element, that's every unit is about 40 degrees. So it says in the procedure that to put the oxalate water and gently heat in order to dissolve the oxalate. So I'd set the hot plate to about 2 or 3. That's about 120 degrees if that. So you just need to get water to start to not boil, but to warm up. So set up, put the hot plate back on the stand, put the spinner in, If you have a big flask and you drop it from the height, I've done this, and it's a big heavy weight, you smash the flask. I've done that. So when you put the flea in, the magnetic bar, put it in at the side and let it just gently trickle down. Don't drop it from the height and go smash. I've done that a few times. And you often think, now why did I do that? Because you're not thinking correctly. Right? So just let it drizzle down. So now it says, go and get some water, 20 ml. So there's a water bottle over here. Here's one we did prepared earlier. Get yourself some water. Now, you can be really accurate and go and get a measuring cylinder if you wish, and get 20 ml in a measuring cylinder, and then put 20 ml by the measuring cylinder into there. But I like bucket chemistry on an inorganic crack. So I'll just look at the flask and I'll just judge what I believe to be 20 ml. I'd recommend though you as students go and use a measuring cylinder. I'll rinse around the side of the flask as well with the water to make sure all the oxalate dissolves. We'll set it spinning. There we go, getting it to spin away. Maybe a bit more water. And then it says go and get yourself 8 ml, sort of 4 ml of the ferric solution. So you can either get yourself a measuring cylinder if you wish, and down here there are some plastic pipettes. Today, if I was using 4 ml, would probably just use the pasta pipette to measure out 4 ml, but let's be as careful as possible. Just to say to you as well, using pipettes, if you put a pipette in and suck up, sometimes on a cold day, if the pipette isn't the same temperature as the solution, it drizzles out. I say to all students, when you put pipettes into solutions like this, if it's a plastic pipette or glass one, up, down, up, down, up, down, up, down, get the solvent, the liquid at the same temp at the pipette. It doesn't drizzle out all over the place. This is a water-based solution today, but other things you can do with pipettes like ether, there's a temperature differential and it will drizzle all over the place like that, not what you want. So get yourself 4 ml. So we'll put it in the measuring cylinder that way. Quickly get 4 ml. So do it at eye level, get down to eye level for the meniscus, that's fine. That's 4 ml. And like it says now, just drizzle it in and heat at the same time. So set the hot plate up to 2 or 3 on the dial and get heating as well. And that's the first part of today. Cut. Thank you.